The world is more energy hungry than ever before, and it's accelerating. That's the reason why we are using more fossil fuels today than ever before. What could be the solution? Like in most things in natural science, it's Mother Earth. Our planet is an immense energy battery. 99% of the entire mass of the Earth is warmer than 1,000 degrees. We are sitting on a fire planet. And this represents immense natural energy that is available 24/7, winter, summer, every day, regardless of seasonal changes and weather conditions. The principle of deep geothermal energy is nothing new. The Italians started this already 100 years ago outside Pisa, a location called Larderello. They produce close to 1,000 megawatt in Larderello today. But that's still old school technology. And we are now presenting the next generation, the deep geothermal 2.0. That is the result of 7 years of very hard work to find the best technology to make this principle of drilling deep wells to access the heat. Down there here, depending on where we are, it can be several hundred degrees Celsius. On Iceland, it's between 300 and 500 degrees Celsius, but they are on a very rare location on the Earth. Indonesia is located on so-called ring of fire. That's where you have all the heat along the tectonic plate lands. Sweden is something different. We have very old base of granite crystalline bedrock. It's relatively cold here, and it's also very hard. So how do we succeed doing this with all the learnings from Kenya, Indonesia, and Iceland, and Northern California, the countries that have started the exploration of deep geothermal energy? Well, the first secret how we solve this is a new method how to reach the sufficient depth. We are talking about several kilometers, depending on the local gradient. Here in Sweden, the temperature increases approximately 20 degrees Celsius per kilometer. So if we want 100 degrees, then it's 5 kilometers. In China, the gradient is much more favorable. So there the heat is on less deep locations. But it all differs, and the most extreme locations are Iceland, Kenya, Indonesia, and Northern California. We have developed a concept whereby we can provide now virtually any city or any industrial park with renewable, emission-free baseload energy. No transportation of fuels, no waste, no emissions. It's a closed-loop system that captures the heat deep down in the bedrock. But the challenge has been to develop a method how to capture the heat. It's not only about reaching a certain temperature, it's also about capturing sufficient energy to provide for Changshu as an example. And there we are presenting a solution now, a solution of soft stimulation of the hot bedrock so that we can create very fine microfractures in a controlled way, and thereby establishing a very, very large heat exchanger that can capture the heat. We circulate water in this through a closed-loop system going round, 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 and it captures constantly the heat that is reproducing itself automatically. And to put this in a market context, this is shallow geothermal. This is what we call bergvärme in Sweden. 200-300 meter and heat pumps. This is for heating and cooling of single buildings. This red spot, that's Iceland, Kenya, Indonesia. That's the very extreme locations on the Earth. But that's not relevant for Sweden and Changshu. That's why the business potential in